Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. Today, I'm going to give you an introduction to integers. Integers are all counting numbers, the number 0, and all counting numbers as their negative opposites. Counting numbers are literally the numbers that you learn to count with. So when you're a little kid, like maybe a baby, and your mom is teaching you how to count and you go 1, 2, 3, 4, those are the counting numbers. The number 0 is not typically a counting number. People aren't taught to count with 0. People aren't taught 0, 1, 2, 3, 4. So integers are counting numbers, the number 0, and then all those counting numbers, but with a negative in front of it, which is that number's opposite. So I'm calling it the negative opposite here. So counting numbers on my number line that I have here are 1, 2, 3, 4, 5, 6, 7. Then remember also integers are 0. And then all of those numbers, 1, 2, 3, 4, 5, 6, 7, in their negative form are also integers. So -1, -2, -3, -4. When you're looking at a number line, you need to remember that no matter how the numbers look, all the numbers to the right of the number line are gradually getting larger and larger and larger. The numbers to the left of the number line are gradually getting smaller and smaller. So just like 6 is less than 7, 5 is also less than 7, 4 is also less than 7, and -2 down here is also less than 7. -3 is less than 7. -4 is less than 7. So that also means that -4 is also less than -3 because it's on the left side of the number line. Like I said, all the numbers on the left are lower than any number to the right of it. So this 6 is less than this 5, even though that seems reversed in what you're used to thinking. 5 would be less than 6, but in this case, because the number is negative, the numbers work in reverse. You can think of it as, this is really like saying you have less than 0. It's like, this is like owing money to a friend. So if I have $0, I would be at 0. If I owed a friend $1, I would be -$1. That means if I went to work and I earned $1, when I first get that dollar, I need to pay my friend back. So it's like I have less money than $0 because I borrowed money from somebody. So the further in this direction, the further left you go, is the more you have that is less than 0. Okay, let me move into some examples so we can make sure we understand which numbers are larger and which numbers are smaller than each other when we're dealing with integers. For the first type of example, we're going to circle the integer with the largest value. So for example number 1, we have 56 and 59. These are pretty easy. They're still integers because remember, we learned that integers are the counting numbers. So this one's easier because we don't have any negative numbers to deal with. So if I'm to circle the larger number, the number with the largest value, that'd be 59. So that's pretty simple. But what about this one? We have a negative number. We have 8 and we have -8. If you remember, just like I explained in the last slide, negative numbers are less than 0. So although they have the same appearance generally, except for the negative sign, the +8 is definitely more than the -8. The +8 is like saying you have $8. The -8 is like saying you owe your friend $8. That's less than $8. The last example is -12 and 0. This might seem a little tricky because you may think, oh, 12, that's an actual number. 0 means nothing, so 12 would be larger. No, that's actually wrong. 0 is larger than -12 because 0 means you have nothing. -12 means you're in the hole. You actually owe somebody. So as soon as you do get somebody, it's going to go away from you and go to somebody else because you have to pay somebody else back. Let's move into a different type of example to make sure we understand integers. Example number 2 says, order these integers from least to greatest. Okay, in order to do that, I'm going to think about a number line, just like I showed on the last slide. If I think about that number line, I'll remember that all of the numbers in relationship to my 0 that were positive or did not have a negative sign were on the right side. So I'm going to start with 0 and write it down. So let's see, I'm going to put my 0 right here and a comma. Now, I'm not going to deal with the -2 right now. I'm going to hold off on that and just deal with all my other numbers that I have. I've already used a 0, so I'm going to cross it off. So right now I'm only dealing with a 1, a 5, and a 2. I can order those from least to greatest pretty easily. I know that 1 comes first, then 2, then 5. So I'm going to write that part in. And I know that it goes to the right of the 0 because remember that number line that I showed you on the first slide showed all of the positive numbers or the regular counting numbers that you're used to dealing with, ever since you're a baby, were on the right side. So here's my 1, a comma, my 2, a comma, and my 5. I'm going to cross out all of these because I've already used them, and now I just have my -2. And remember, all of our negative numbers were on the left side, so I'm just going to add my -2 and put a comma. So if I'm going to order these numbers, the integers from least to greatest, it would be -2, then 0, then 1, then 2, then 5. Here's another example. I have a 1, 5, -20, 0, and 7. I'm going to start with 0 again because that's kind of a nice place to start. I have my 0 and I'm going to deal with all my positive numbers first. Just kind of simplifies it for me because I'm pretty good with positive numbers. I know which numbers are larger and smaller when I'm dealing with positive numbers. So I have 15 and I have 20. And I know 15 is less than 20. So if I'm going to order from least to greatest, I know 15 is going to be next. Then I know 20 would be after. So now I'm going to cross these out. So really by going, just doing my 0 first, then my positive numbers, I really help myself out because now I only have a couple of negative numbers left. And that's not that bad. So I just need to remember though, which comes first, the -5 or the -7. If you remember, I'm on the left side of the number line, the numbers closest to 0 mimic the numbers that are on the right side immediately. So the opposite of +1 would be -1. So the opposite of 3 would be -3. So we're going to graph both the 3 and the -3. I'm going to just put a comma -3 because that's going to be the opposite on a number line. So I'm going to draw a number line and I'm going to put arrows because remember, numbers never end. I'm going to put my 0 just to give us like a good base, a good starting place. And I'm going to draw 1 notch, 2 notches, and 3 notches. And that's for my 3. And I'm going to draw 3 notches this way. 1, 2, 3. Okay, so if I'm going to graph, I'll just put a dot in each position. So I have graphed the number 3 and its opposite -3 on the number line. Example number 2 has a 4. So remember, the opposite of the number -4 is going to be +4. I'm going to draw another number line. I'm going to start with 0 again. My -4 is going to be over on the left side. 1, 2, 3, 4. I have a -4 here, and my +4 is going to be on the right side. 1, 2, 3, 4 over here. Draw a dot at each point. And I have graphed -4 and 4. Last example is -21, no problem. The opposite of that is going to be +21. I am not going to draw 21 notches going in both directions coming from my 0. I will draw my 0, and I'm going to skip count by 5s this time, which is totally okay to do. 5, 10, 15, 20. I'm actually going to write in 20, and I'm going to put 5 here. And I'm actually going to just put my dot on the 21 position, but not actually write 21. That's okay to do sometimes. Sometimes if you're dealing with numbers that are really large, like 500, and you have to graph that, you're not going to spend the time writing each notch out. So sometimes you need to, skip count and abbreviate those notches. If I was going to write something up to 500, like I mentioned, I might count by 100. So this might be 100, 200, 300. And I will clarify here 5, 10, 15. That way it's very clear to know that, okay, this is one space after, that's a 21. Okay, so this is -5, and this is -10, this is -5 and -20. Put one more notch and put my dot here for -21. Now let's move on to absolute value. Okay, so the first example says, find the absolute value of the integer. And absolute value literally just means the distance away from 0. So if I were to think of a number line, I would know that my 0 would be here, and I would have a 15 down here somewhere, and there would literally be 15 notches. Each notch counts as 1, and as long as you're talking about each notch is one place in between, one integer in between, so the absolute value of 15 would be 15 because it's literally 15 spaces away. Example number 2 is -6. This is going to be the same, but in reverse. Okay, so I have a 0 here. I can go 1, 2, 3, 4, 5, and 6 notches to the left, And that's going to tell me that I have 1, 2, 3, 4, 5, 6 spaces in between -6 and 0, meaning the absolute value of -6 is 6, positive 6. I do want to point out that an absolute value can never be negative. It must always be positive, and that's because the absolute value you can never measure a distance negatively. A distance has to be positive. To measure the distance from one space to another space must be a positive value. It can't be negative. The absolute value of -81 is going to be 81. I'm not going to draw a graph for this one because really we just know that that just means 81 spaces to the left of 0. And the absolute value is only asking me how far it is away from 0, not which side or anything like that. I hope this video helped give you a good basic understanding of integers. That was my last example. Thanks for watching.